ourselves to the first order differential equation today. Now, what is a first order differential equation? Before getting to that, we'll discuss what is a differential equation. In short, any equation which contains a differential term, i.e. the derivative of a dependent variable with respect to an independent variable, is called a differential equation. Now, linear differential equation is one of the most common types of differential equation. We can identify it majorly in two forms. A differential equation of the form dy by dx plus p multiplied by y is equal to q, where p and q are constants or functions with respect to x only. This is one of the forms. There is another form which is less common, but you might also see. In this form, it is dx by dy plus p1x plus is equals to q, where p1 and q are constants or functions of y only. Now, we will see methods of solving such differential equations, and this method is called integrating factor method. Now, in any given question, we will be given a differential equation. Now, our first job is to simplify the given equation to one of the standard forms. Then, we will identify p and q from it. Then, we will try to identify the integrating factor. The integrating factor is given by e raised to the integral of p with respect to dx. Then, the solution of the linear differential equation is given by y multiplied by integrating factor is equals to the integral of q multiplied by integrating factor with respect to dx. Now, to understand this concept, we will do some examples. Here, we are given a question. dy by dx plus 3y is equals to e raised to minus 2x. Now let's recall the general form. On comparison, we identify that p is 3. And q is e raised to minus 2x. Now we have to find the integrating factor. The integrating factor is given by e raised to integral p dx, and we have p is equal to 3. And we get the result as e raised to 3x. It is to be noted that the integral of p dx, we do not consider the constant of integration. Now, we know the solution of a differential equation is given by y times integrating factor is equals to integral q multiplied by integrating factor Now substitute substituting the values, y multiplied by e raised to 3x is equals to integral q we have e raised to minus 2x multiplied by integrating factor we have e raised to 3x. Now we can simplify the RHS using loss of exponents, and you will get the result integral of e power x dx. E power x dx, and we know the integral of e power x is equals to e power x. And we should also, here we should include the concept of integration. Let's see. Now we can simplify this expression further. Now we will write the expression once more. Y is equals to e power 3x is equals to e power x plus c. We can take this e power 3x to the RHS by dividing the whole expression by e power 3x. We will get the result y is equals to, this will result in e power minus 2x plus e power minus 3x multiplied by constant of integration. This will be our solution to the first order linear differential equation. Now, we will see another example. Integration constant. Like any time when we integrate, we will get a family of curves. To represent all this, we use constant of integration. Integration and differentiation are opposite of each other. So when you differentiate this one constant, it will be not same. So you will get the same value. That's why. Now we see the given example, given question. Now we can simplify this further by taking any one term to the RHS. So we will take this term to the RHS. Y dx is equals to negative of x minus y square dy. Now we will take this dx term to the right side and this x minus y square, negative of x minus y square term to the left side. We will get the result y is equals to negative x minus y square is equals to dy by dx. But here you will run into issue. This is we can't simplify further this one. Hence we will take the reciprocal on both sides, and we will also take the negative inside. Then this will result in a negative and this will result in a positive. By taking reciprocal, we will get dx by dy is equals to y square minus x by y. We can simplify this into y minus x by y, and we can take this x by y term, negative x by y term to the left side, dx by dy plus x by y is equals to y. We have gotten this. This is the second form of first order linear differential equation. Now we will compare with the standard form. Recall dx dy plus bx is equals to q. On comparison, we find that P is equals to 1 by y, and Q is equals to y. Now we will find the solution. Now we know the solution is given by y times integrating factor. So first we have to find the integrating factor. We have the integrating factor. In this case, for the second form, is given by e raised to integral p with respect to dy. Now we know we have to substitute the value of p here. It should be e raised to integral 1 by y dy. We know the integral of 1 by y is ln y, natural logarithm of y. Y, and we know from the law this we can simplify it further to y itself. We got the integrating factor as y. Now we will substitute in the solution. We have y multiplied by integrating factor. What is this? Here, since we are dealing with the second form, it's x. Yes. So it will be x multiplied by integrating factor is equals to integral q multiplied by integrating factor times dy. Now x, we got the integrating factor as y, is equals to integral we got this one as y is equal q is y, and integrating factor is also y. This will result in integral of y square dy. Now we know the integral of y square is y cube by 3. And we should remember to include the constant of integration. Now we can take this y term to the RHS by dividing the whole equation with y, and we will get the result x is equals to y square by 3 plus c by y. This is our solution to the given linear differential equation. Now linear differential equations are used in many fields such as physics, biology, engineering, economics, many such fields, and they have many practical uses also. Differential equations are used where it is much easier to quantify change rather than the actual quantity. Now, in the field of biology, linear differential equations for the first order are used to plot the population growth and decay. For example, we can use linear differential equations to plot India's population growth. In engineering, especially electrical engineering, other fields of engineering also, we can use linear differential equations to show the characteristics of some electrical circuits. Linear differential equations also can be used to predict the weather. Linear differential equations are used for numerical weather prediction, and these are used by weather forecasters to predict the weather. Any questions? Yes, we can use linear differential equations to show how markets perform, work, and we can also use it to make some predictions. Yes.
You explained how to find the general solution of a given equation, but what if we want to find a particular solution?
We still steps for finding a particular solution is very similar. We have to find the general solution first. Then in the question itself, they would have given some conditions, and we will substitute the conditions in the general equation, and we will find the constant of integration. Then we will substitute the constant of integration back in the original general solution, and we get the particular solution for that question. Thank you. That concludes the discussion.